MADlib began through my work as a professor at Berkeley, consulting with folks at a startup company called Greenplum that was developing the Greenplum database. And they had a customer, which at the time was Fox Interactive, which was a division of Fox that managed ad tech for MySpace. And the ad tech guys at MySpace at that time were actually doing very high-end machine learning using an SQL database. So they had scripted sort of the latest in machine learning algorithms over a database system. So I went to talk to those folks and learned a lot actually from these data scientists in the field about how you can take advantage of the parallel processing power of a MPP database and do sophisticated algorithms. So what I saw there, I said, other people are going to want to do this. Let's take the ideas, let's do some more robust engineering, and let's release this as open source.
The main users of Apache MADlib are primarily data scientists who are working with very large data sets. MADlib really shines when the data sets are very large and need an MPP architecture in which to operate on them.
So the acronym MADlib stands for M, magnetic, A, agile, and D, deep. The magnetic piece has to do with bringing all the analysts and all the data in your organization into one place. So that today we would call a data lake. The A was for agile, and the idea of getting analysts to be able to quickly develop hypotheses and test them with statistical algorithms and then build code in an iterative fashion over the statistical methods. And the D part was to capture the idea of depth, that these statistical methods are really quite deep. They're not simple roll-ups and drill downs. They're sophisticated machine learning and probabilistic methods. So we wrote about this actually in a paper at the VLDB conference. We talked about the idea of mad analytics and mad skills, and that was actually very widely received and cited. I got brought into Google and other places to talk about this as a philosophy.
The art and science of developing a MADlib algorithm is to implement it in such a way that it can take advantage of the distributed nature of an MPP database, and also to implement the algorithms in an efficient way with respect to processing, scale, and network bandwidth.
MADlib was built on SQL for the simple reason that the data that a lot of people have is in a SQL database, and they're working with that data through the SQL interface. What we wanted to do was bring the machine learning technology to the data. So traditionally, analytics packages like SAS and R, SPSS, are desktop applications, and they have machine learning algorithms and statistical methods that have been implemented that won't run in parallel. And it's quite tricky actually to figure out how to take an algorithm that's been implemented for something like R and parallelize it. When you start from the ground up with a parallel processing infrastructure, like an MPP database, you begin to think about a data-first way of building algorithms. And using the power of many machines and data partitioned across those machines, you can drive machine learning algorithms if you write them in the right way. So when you're taking the algorithms to the data, so to speak, when you're looking to do the analytics close to where the data lives, if the data is living in a parallel compute engine, you'll design statistical algorithms that match that architecture. And that's exactly what we did with MADlib.
Because it's a general purpose library, MADlib is used across a wide variety of industries, from manufacturing, financial services, government, and healthcare. We get a lot of requirements from data scientists, so we listen very carefully to them to find out what algorithms they need for their day-to-day work. On the development side, the committers to MADlib then take these ideas and examples from the data science community and figure out how to implement them in a scale-out manner.
So MADlib brings machine learning technologies to an environment where you have SQL, storage, and scalability. And in the big data open source community, you can get all three of those things now decoupled into different pieces and put them together in interesting ways. So for example, the Apache Hawk project is an SQL query executor with a robust, mature query optimizer underneath it that runs in the Hadoop context over HDFS. And you can put MADlib into Hawk. It's deeply integrated, so you can really be doing these machine learning algorithms in a very Hadoop native context today with mature technology.